Hello, we are the team number 5 from the group 50, and this is going to be our math project in which we're going to explain what we saw all through the first partial. So my group is conformed by
Alberto Varela,
Eduardo Moraes, Diego Martínez,
Francisco Romero,
and Alejandra Gudiño. Also, for a really brief introduction to the subject, we will be having first of all the rational function, which, its graph looks like this, as my partner Dave already mentioned, and the general formula will be this one. The basic formula for this rational function, it consists of two different equations within one. It is r of x is equal to p of x over q of x, in which both are different polynomial equations. This is a rational function is a correlation between two different groups of numbers or values. In this case, the group of x and the group of y. And as we have already know, the asymptotes are points on the graph that determine a specific point or area within the graph that it never touches. So for example, in this case with the normal equation, it will be 0 and 0.
So to identify if we have a horizontal asymptote or an oblique asymptote, first we need to see that the exponent on the top needs to be bigger than the exponent on the bottom part. After this, for obtaining the vertical asymptote is the same as every rational function. But here we can see we have to isolate x, so the result is -3. There is nothing different in that part. But when we talk about oblique asymptote, is where it changes. So first, what we gotta do is to make a large division. So I suppose you already know how to make like a large division. So in this case, the result will be x plus 2, for example. And so the oblique asymptote is the result of that division exactly. So and when it comes to graph, we can see that the vertical asymptote in this case is -3. We're following the asymptote, and in the oblique asymptote, we can see that is x plus 2, which means it's a linear function. So what we gotta do is put move two points upward, and we will have the oblique asymptote.
The absolute value is a function that has these little bars surrounding x that makes all the values of x positive. Like in this example, the -1 absolute value, it will make positive 1. Also the -2, it will convert it to 2. And then you have to graph it. This is the first or the original function, the graph of the absolute value. Here we can see the 0,0 and the 1,1 and obviously the 2,2. And it could be a reflection in the y-axis, that it's the same but just with x as negative. The first one is a rational function, so the first step to graph this one is the movement to the left, or a shift to the left. So in this one you can see that this is the first point, and you will move 2 points to the left, and this will be the vertical asymptote as shown here. Okay, and then to take out the horizontal asymptote, you have to see if in the numerator and denominator you have the same exponent, but as in the numerator there's no exponent, the horizontal asymptote will be 0, so it's the same horizontal asymptote. And the last step is the reflection. The reflection, it will be the sign outside the fraction, and the negative out of the fraction, it means reflection in the x-axis. So the first one, it will be here, and then it will pass over here.
So then the second one is pretty easy. We have 1/2 of x plus 2. So what we have to do, or what we can do first, we can first shift 2 spaces up, and we can have this 1, 2. We find the point 0, 2, and then what we have to do is to search other points. So we have the function of 1/2 x. So we know that for every y we move, we are going to move 2x. So for example, we move 1 y down, then we will move 2x to the left, 1, 2. We have the first point here, and vice versa. We move 1 up, we move to the right. And we have then the restriction that says that it can't be smaller than -2, and it can be bigger than 2.
So the last function in this piecewise is an absolute value. So first we need to identify the shifts that we need to do. So first we have a -1, that means you move 1 to the right, and then you have 2 outside the absolute value, so it means you go 2 up and start graphing. You move 1 by 1, so it will be like this, but you have the restriction there. It says that it needs to be bigger than 2, so this one it cannot be, and it goes to the infinite.
So as you see, this equation has 3 functions: a rational function, a linear function, and an absolute value function. As you can see, there are no empty points in this equation. The intersection with the y-axis is 0, 2, and there is no intersection with the x-axis. The domain of this equation goes from -infinity to infinity, and the range is all natural numbers.
Thanks to this project, I've learned about how to use these kind of functions in my daily quizzes, and I think that I could use these functions in future issues of the matter.
So with this project, I have learned that the simple functions such as the linear and the quadratic functions and all of those can be combined in the piecewise functions. And also I have learned to use the new type of functions such as the rational functions, their behaviors, and how to graph them and write their formulas. And I think this will be very useful for the daily basis.
Well, so for my part, what I have learned with this project is that there are many different ways in which we can combine the functions, and not necessarily they have just one use. So we can apply these different things, and this project taught us how to try to think the difficulties or problems of the daily life with different kind of mathematical logical thinking, and also to work in team.
So for me it was pretty interesting, the fact of seeing from the simplest function that we have, that could be the linear or the constant, to see how we can combine them in a simple graph in the absolute, with an absolute value function that it's a little bit more complex than the other ones. So it was awesome to see the way that we can join, or that we can group up all these functions to get a final result.
In my opinion, I think that the piecewise functions help us in daily life problems such as mathematics or in every type of value issues.